In this episode, we're going to talk about a concept that helps understand randomness. Directionality is important in understanding the movement of molecules in liquid form. What is diffusion? The classic definition of diffusion is that it is the flow of molecules from a place of high concentration to a place of low concentration. You have a beaker of water and you put in a drop of food coloring, and that drop of food coloring will eventually spread throughout the beaker such that eventually the whole beaker is now pink. After learning about diffusion, students then learn about something called osmosis, which is a special case of diffusion. Osmosis is defined as the movement of water molecules across a semi-permeable membrane from a place that is less concentrated to a place that is more concentrated. In other words, water will leave a salty solution to join another solution that is even saltier. Semi-permeable membrane in this case means that only water can cross the barrier that divides the two solutions. In osmosis, water molecules are constantly going back and forth in a random fashion across the membrane. In order to understand osmosis, it's important to understand the molecular structure of water. On the left is a single water molecule. Water has one end that is slightly negatively charged and the other end that is slightly positively charged. On the right is a sugar molecule. Sugar molecules also have parts that are slightly positively charged and negatively charged, and it's these opposite ends that attract each other. Thus, water behaves like many mini magnets. In the case of a spoonful of sugar in a glass of water, the sugar disappears because water molecules surround each sugar molecule and do not allow the sugar molecules to form a solid crystal. We have water molecules that are busy interacting with a sugar molecule, and then we have water molecules out here that are free floating, and they're constantly going back and forth from being busy to being free and floating around. In osmosis, water will move from the side that has less sugar molecules to more sugar molecules, and so the water level will be uneven. But the question is, if water molecules constantly go back and forth in a random fashion, then why does the water level stay uneven? The reason is because osmosis is a random and directional movement of water. The side that has more sugar molecules keeps water molecules busy. So though water molecules are constantly moving back and forth, when they're on the right side, they're often busier, and thus they spend more time on the right side. Consider this image here of water being poured out of a bottle. The water molecules in the bottle are moving randomly in all directions. So are the water molecules in the stream that's being poured out. Though these molecules are moving in random directions, collectively they're all moving in one direction, that is out of the bottle into the cup. The random and directional movement of water is important when physicists and engineers simulate the flow of fluids right through different compartments. Notice that the fluid doesn't move in a straight line, though to the human eye, all you would see is water going in and then water coming out. However, if you track the molecules, right, or estimate where they are and how fast they're moving, you would find that molecules actually don't move in a straight line, zigzagging out. Sometimes they go into these swirling patterns. So while water is moving randomly within this liquid system, they're collectively moving from the left to the right. In summary, a physical system that changes over time can be both random and directional. In other words, randomness can have directionality. This concept is important in understanding how people mix chemicals together to create drugs or to create new chemicals.